Here we are going to solve problems probability related. So 10 people are checked for vitamin deficiency. 10 people we have. And 25 people are tested for virus infection. What's the probability of a person having vitamin deficiency? So this is the first part of the question we need to answer. And then more than 20 people are tested negative for the virus infection. Okay, what's the probability of a person having vitamin deficiency? Probability of the person having vitamin deficiency is, we says a person, which means it's only one person. And how many people we have checked for vitamin deficiency? 10. So it will be 1 over 10, which equals 0.1. Okay, now second one, or remember one thing here, when it's two questions connected with the end, that means you have to multiply them. So, what's the probability that more than 20 people are tested negative for virus infection? So total we have 25, so more than 20, it's gonna be, how many people will be more than 20? 5, right? 21, 22, 23, 24, 25. So it's gonna be 5 people. So probability for tested negative. Tested negative. Okay, this is equal. So 5 out of 25, because above 20, more than 20, is going to be 5 more. And total 25, this will be 1, this will be 5. So we get 0.2. So if we need to find the answer, probability of vitamin deficiency, and we have and, we put multiplication, probability of tested negative. It's going to be equal 0.1 times 0.2, which will be 0.02. That is 2%. Next. Suppose 60% of teenagers accepted to sport club like to play basketball, and 50% like to play basketball and softball. What's the probability that a teenager accepted to sport club like to play basketball and softball? The key word here and, which means we will end up doing multiplication again. So the probability that teenager accepted that to the sport club like to play basketball and softball. All right, let's see. So 60% like to play basketball. So which means probability of basketball. So 60% is going to be 0.6. Okay, and probability of basketball and softball here is 0.15. So we want to know what's the probability that the person accepted to a sport club like to play and basketball and softball all together. So total probability, it's going to be equal basketball and basketball with softball. Okay, and that is equal 0.6 times 0.15. So 6 times 15, 6 times 5, 36, 90. So 1, 2, 3, 0.9, which is equal 90%. Next question. Here you have Pareto chart for text messaging of students for the months January, February, March, April, and March, April, May. Okay, June. Assuming there is in May did not participate in survey. So, A, find the probability of randomly selected student did text messaging equal to January text messaging. Equal to January. Okay, that's already enough January. We can put full stop there. So, for January we have probability for January. So for January we have 134. Oh, 134 over, how much is all this total? Let me see real quick. If I add them up, it's going to be 134 plus, well, I can do it here. 134, 120, 110, 80, and 60. So what do we have? This is 4. So 5, 6, 14, 20. Okay, 0, 2 in mind. 1, 2, 3, and 5. 504. There we go. So 134 divided by 504, it's going to be equal approximately, tilde sign, equal approximately 0.27. Okay. Find the probability of randomly selected student did text messaging in March. All right. For March, how much is March? 110. So probability for March, it's going to be 110 over 504. Can we reduce by how much? By 2. Will be 55. Yes? By 2, it's going to be twice 4, 10 by 2, 5, and 252. Next question. Oh, 50, now we need 55 divided by 252, and that will be 0.22. Okay, next question. Find the probability of randomly selected student did text messaging equal to June or April. June or April. So for June, what do we have? 60 out of 504, right? Probability of June is equal, how much we said? 60. So it's gonna be 60 out of 504, because total we saw it's 504. Then April. How much is April? 80 over 504. So 60 by divided by 504. Can we reduce these both fractions? Actually, it will be easier to add. Let's leave it alone because we need to add here. See, it says June or April. Remember when I told you when two probabilities connected with and, then it's multiplication. If they are connected with or, then it's going to be addition. Therefore, it's going to be probability for June plus probability for April, and that's equal 60 over 504 plus 80 over 504. 140 over 504. 504. Okay, here we can, I guess, reduce. So let's reduce by 4. 14 divided by 4 is 3 times 12, and remainder is 2. 20 divided by 4 is 5. 5 divided by 4 is 1. So 4, remainder is 1. 10 by 4 is 2. 24 by 4 is 6. 35 over 126. Now let's divide 35 by 126. And that is going to be equal approximately 0.28 or 28%. Next. Find the probability of randomly selected student that did text messaging equal to March or April. Okay, we have for April right here 80 over 504. So let me write down probability for April. Can we reduce? Well, let's try. Okay, well, no, let's keep it because it's easy to calculate. And then for March, is going to be equal. For March, where is it? How much we have for March? Oh, 110 for March. 110 over 504. So probability for April or March. See, because we have here or, so we are adding. It's going to be equal 80 over 504 plus 110 over 504. So is equal 504. Our 10 plus 80 will be 190. Okay, can we, well, we can might as well divide 190 divided by 504. 0.38. So next problem, probability related, is find probability from this table. So what do we have in this table? We have the owner of the computer, yes or no, either own or not, and at the same time going to the summer vacation, yes or not. So first question is find the probability that a person not going on vacation, or it's very important, which means it's going to be plus. Let me write out here. If we have or, we end up adding. If we have and, we end up multiplying. Okay, so find the person that is not going on vacation or does have computer. So how many total people are not going on vacation? Here, vacation, not going on vacation, total is going to be 40, right? So probability not going on vacation is going to equal 40 out of total 115, grand total. Okay, probability of people who does have computer, this is second part. How many people have computer? Here it is, yes. Total will be 90, yes? So it will be equal 90 over 115. But now look what is interesting here. We can picture. So not going on vacation, it's this one, right? And having computer is this one. What do we see here? We see that this number 30 repeating twice among people who not going on vacation and among people who yes have computer. Therefore, so total is gonna be no vacation, let me write down short, no vacation, plus probability of having computer, and we need to subtract this 30, otherwise it will duplicate. See, this 30 we count when people are not going on vacation, and 30 we count when we say yes, people have computer. So it's repeating twice. So now we need to subtract people who not going for vacation, no vacation, and have computer, because it's 30 people not going on vacation and have computer. All right, so this is going to be equal (40 over 115 plus 90 over 115 and minus this 30 over 115. So 40 plus 90 will be 130, minus 30 will be 100. 100 over 115. And that is going to be 100 divided by 150 and approximately equal 0.67, which is 67%, right? Next question. What's the probability that person does not have computer, or, marking down or, which is going to be plus, right? Does not have computer or going for vacation. All right, Let's see, what is doesn't have computer? How many doesn't have computer? Let me change the color so we can see. Okay, I take this one. So doesn't have computer, no computer here. So total 25, right? So what do we have? Probability of no computer. It's going to be total that don't have computer is 25, yes. Over grand total is 115. And going for vacation, how many are going for vacation? Yes, going for vacation, here it is. Total 75. Over 150. Do we have here overlapping? Yes, that is this 15. Yes, don't have have computer, and yes, go on vacation. This 15 overlapping, which means we're gonna do probability of no computer plus probability of vacation and minus probability of no computer and vacation. So that is going to be equal. No computer will be 25 over 115 plus probability of vacation. It's going to be 75 over 115. And the intersection overlapping, it's a 15 over 115. Okay, 25 plus 75, it's going to be 100. 100 minus 15, it's going to be 85. 85 over 115. So 85 over 100. 85 over 115 is approximately 0.74.